Today we'll talk about the Biot-Savart law. So this law concerns itself with the strength of the magnetic field due to a current carrying element. So in real life you have conductors, your wires, your conductors that carry current, and these current carrying conductors are responsible for generating a magnetic field due to the flow of charges. Now what is the strength of a magnetic field thus produced? That's what the Biot-Savart law tries to decipher. So to understand this law a little more in depth, let's consider a simple current carrying conductor. So let's say it's carrying a current I, and there's a small piece of this current carrying conductor that I am interested in of length dl. Now this small length of this conductor, as current flows through it, it generates a magnetic field of some small strength that I will call as dB. At a distance, let's say at some point A, which is at a distance of r, which is at a distance of r from the current element. Now, the Biot-Savart law states that the intensity or the strength of the magnetic field is directly proportional to the current flowing through the conductor, or in other words, the current flowing through the small element that we are concerned with here. And it's also directly proportional to the vector product, of the current element and the distance of the point that's of concern to us from the current element. And it's also inversely proportional to the square of the distance between the current element and the point of interest. Now, since it's a vector product, when I represent it as a cross product, when I resolve the vector, I tend to denote it as I dl into r sine theta divided by r cube, because the r that's introduced in the numerator, I wish it to get cancelled and restore my denominator term to a square term. Also, you might be wondering, where did this sine theta come from? So the sine theta is the angle between the distance, the line connecting the current element with the point A, and the tangent to the current element. So this angle is theta. So if this is the case, then to remove the proportionality sign, I introduce a constant k I dl sine theta by r square. So since I have resolved the vector, I am only concerned with the magnitude, so I can take the modulus on the left hand side. So this proportionality constant is what is called as the permeability of free space. It's called as the permeability of free space, and it's given by mu naught by 4 pi. Now this term over here, I mentioned to you, it's called the permeability of free space. So whenever I talk of the word free space, I am referring to the vacuum of space, and this particular constant takes the value of 10 power minus 7. What do you think the unit is? So if you rearrange the terms, you will get the unit to be Tesla meter square per ampere. So it's a very small number, which is about 10 power minus 7 Tesla meter square per ampere. Now you might also have guessed that the direction of the magnetic field. So if you look at this conductor carefully, I have represented the current to be flowing from the bottom to the top. So to find out what is the direction of the magnetic field dB at this point A, all I have to do is take advantage of Maxwell's right hand thumb rule. So I grip this conductor with my right hand fingers encircling the conductor and my thumb pointing in the direction of the flow of current. If that's the case, my encircled fingers indicate the direction of the magnetic field. So which means since they are going in here, the magnetic field is going in here and coming out from here. So which means by convention I represent the magnetic field at this point this way. And if there had been another point, let's say B over here, then I have represented the magnetic field here with a dot because the magnetic field is coming out here from the board, whereas here it's going into the board. See, for all this, remember, you will have to visualize everything that we put on the board in terms of 3D space. So when I say consider a conductor, I am actually asking you to consider a wire that is in 3D space. So I am more concerned about the magnetic field intensity due to the magnetic field generated by the flow of current in 3D space. When I say at a point distance r, I am interested in not only the distance r, but the distance r traced out in 3D space. So that's what I am interested in when I talk about the magnetic field dB. So at this point, it warrants a quick comparison between one of the laws that we studied in the first chapter versus the law that we just studied in detail. So we have the Coulomb's law, which we dealt in detail in the first chapter, which concerned itself with the electrostatic field being generated by a point charge, versus the Biot-Savart law, which deals with the magnetic field being generated by flowing charges in a current element. Now, how do these two laws compare themselves? So both of them are long range in terms of their influence, because the field being generated in either case, one being the electrostatic field, the other being the magnetic field, they both are long range, which means whatever field is being generated by the element concerned or the point charge concerned, it stretches up to infinity. Just that the range of both of them falls as per the square of the distance, because both of them are the field strength in either case is inversely proportional to the square of the distance. The second thing that you will notice is that the principle of superposition We discussed this in some detail in the first chapter, wherein we said the electric field at a point A due to multiple charges in its vicinity is the charge at that point due to the first charge independent of all others, the electric field due to the second charge independent of all other charges, and so on until you have taken up all the charges independently, and then you superimpose them, which means you take the summation of all the electric fields at that point A due to multiple charges. So the net sum of them gives you the electric field being experienced at point A. This is what we discussed in the principle of superposition. So principle of superposition is also equally applicable to the Biot-Savart law, wherein we can say that if the same wire that is carrying electricity is looped around several times, and I want to consider the effect of the individual current elements, the multiple current elements, the magnetic field being generated at point A, then it's the sum of all the magnetic fields generated at point A due to the multiple current elements. Just that the importance or the care that has to be taken is to make sure each one is added up or superimposed, taking into fact the vectorial direction. The third thing that you will also see is the electrostatic field being generated due to point charges in the case of Coulomb's law is due to scalar static charges. They are scalar quantities and they are static charges, whereas here it's due to the magnetic field is due to the vector, which is the current element, the current flowing through a small piece of the bigger conductor of length dl. The other thing that you will also observe is the electrostatic field is always in the direction of the displacement vector that connects the source charge and the point of interest or the field point, what we call as the field point. So it is along this line. That's the direction of the electrostatic field. Whereas in this case, the magnetic field, remember our magnetic field was something that went into the board and came out of the board when we considered the element that we previously discussed. So you can see that the current element was on the plane of the board and the point of interest was also on the plane of the board, but the magnetic field was perpendicular to this plane. So if I consider this plane of this board, the magnetic field was perpendicular to this particular plane. So magnetic field is always perpendicular to the plane of the displacement vector joining the source, which is our current element, and the field. And the final thing that's to be observed keenly is also as a result of the point that electrostatic field is being generated due to scalar charges, whereas here magnetic field is being generated due to vector current elements. So this also leads us to another point, which is the importance of the angle, the sine theta, that is to be taken into account whenever we are calculating the magnetic field due to a current element, which is not the case when it comes to the electrostatic field that's generated. Another interesting fact of the matter is the two constants that we have encountered so far. So one, we just encountered mu naught. So mu naught, or what we call as the permeability of free space, we encountered it in the Biot-Savart's law, and we encountered the term mu naught by 4 pi for the constant, and we said this value is about 10 power minus 7 Tesla meter per ampere, which implies mu naught alone is equal to, I multiply 4 pi into this term, so I get 4 pi into 10 power minus 7 Tesla meter per ampere. Similarly, in the Coulomb's law, if you recall, we had epsilon naught, and epsilon naught was what we had called as the permittivity of free space. There's a distinction. This is permeability and this is permittivity. And we had encountered the term 1 by 4 pi epsilon naught in the Coulomb's law. And if you remember, the value of this term was 9 into 10 power 9 Newton meter square by Coulomb's law. So now, if I divide this term by this term, it gives me mu naught by 4 pi whole divided by 1 by 4 pi epsilon naught. So on the right side, I'll get the value of this term, which is 10 power minus 7, divided by the value of this term, which is 9 into 10 power 9. So here you can observe that 4 pi and 4 pi cancel out each other. This goes to the numerator, so I am left with mu naught epsilon naught is equal to, I take this 10 power minus 7 to the denominator, so I have 9 into 10 power 9 plus 7. So mu naught epsilon naught is equal to 1 by 9 into 10 power, so 9 plus 7, 16. So I can rewrite this as 1 by 3 into 10 power 8 square. Now if you recall, 3 into 10 power 8 reminds you of something. Yeah, it's the speed of light in SI units. So mu naught epsilon naught is equal to 1 by c square. So the product of permeability and permittivity of free space is equal to the reciprocal of the square of the speed of light.